Hello. All right. Today I'm presenting on the Mendez project. Let me go over here. You can scan things if you want. Contact information for me. Basically, I'm a really weird guy who does really weird stuff. And I don't know how many of you, anyone play Dwarf Fortress, for example? Does anyone know? Okay. So, strange mood. Does that mean anything to you? All right. Every now and then I get one of those, and it's usually, hey, I want to quit my job, I hate this, I'm going to do something crazy. This is one of these projects. So, I tend to make stuff. I don't really care if y'all interrupt, if you ask me questions, if you yell things at me. I welcome abuse. It's totally fun. So, what I'm doing here is we moved to Pennsylvania about 3-ish years ago, and we wanted to have a garden. But I also realized that I'm getting old. My wife is getting old. We don't have any kids, so we're going to need help moving stuff. And, the usual Lancaster County method of, just having a few more kids and bring in the nieces and the nephews didn't quite work for us. So I built something. I just find scrap in this case. It's a 150-pound robot that hauls things. Completely driven by madness. Basically, I just like playing with construction equipment. That's super fun, but I don't like getting killed by it, and I've seen plenty of accidents involving it. I have edited these slides to remove some of the nastier ones that were in here because I was told it might not be family safe.
Thank you, Andre.
Yes, you are welcome. So yeah, basically, I like to build large-scale, large-scale models, drones, aircraft, boats. But in this case, hey, let's take some inspiration from a few places that aren't so nice, and let's give it a different kind of way. So, again, edit and picture. I doodle stuff. So, just had an idea. This is a frame that I'm coming up with. Welded, no plan at all. So I have a past with doing construction, some metal fabrication. That's about everything you can think of. I've tried to do it. So make stuff out of metal. It's therapeutic for me. I guess people work with wood, some people paint. I like white hot metal and melting stuff. So in this case, I built this thing out of electric wheelchair parts and structural steel that I got discounted off of Facebook Marketplace. Because, in this case, you can see the original configuration where I'm trying to, there's some stuff that I should probably remove. But trying to mount wheels, trying to mount everything. This is with zero planning. This is completely just hacked together garbage. Paint it, sand it, all the wonderful things. Do not breathe in what you sand off or what you paint with. So I'm going to go over here so I can see what I'm looking at. 24-volt electrical system. We have 4 motors, so that would be 4-wheel drive, all-wheel drive, whatever you want to call it. It's essentially a skid steer, so 0 turn radius, fun stuff. 2 of these RoboClaw controllers by Basic Micro. I highly recommend them if you're building a BattleBot or you're building an electric lawnmower. They're brush motor controllers as opposed to brushless. Brush motors, like the wheelchair motors, they can have a lot more torque and power than the brushless ones, but driving them is a little bit different, and there aren't as many hobby controllers that are designed for it. The brains of it that I'm using in here, a little Maytech, whatever, it's for an RC plane. I mean, it's what I had in my parts bin, so there we go, that's what it is. For those of you who do anything with drones or RC aircraft, you may have heard of ELRS. That is a major game changer for me on this. The original design was using Wi-Fi and Bluetooth, and no, just don't try that with something that's made of steel and you need to worry about it running you over and hurting you. FPV camera with a gimbal for stabilization. ESP32 running software called Drone Bridge, and again, Caleb, ESP32 is super awesome. You can do just about anything with it. There's libraries for everything. So I can remote control it over Wi-Fi, or I can have a, like a remote control to actually control this thing. Optical flow, I think I described it as like a giant optical mouse. So it can see how fast it's moving over the ground and use that for locating its position. And the GNS RTK, so it's, I'll go into depth on that, but we're talking about centimeter accurate GPS. And this way I can map out, say, my garden, my driveway, the boundary of the property. So if it decides to run away, it'll cut off as soon as it hits that boundary. And big freaking batteries. So 24 volt, 55 amp hour battery capacity. It's a lot. It is way more than I need, but having a large battery storage is useful when power goes out. So, I mean, hey, why not? And then all of the terrible wiring, which I'm not going to get into. Flight controller is, you run a real-time operating system on it. You really have to do that in cases like this, where you need that kind of quick reaction. And I say this not in, I'm worried about my aircraft falling, but in this case, it's a heavy robot with enough power to break bones and rip tendons out of you. So you don't want something to start malfunctioning. And as mentioned down there, I screwed up using it recently, and it got wet and it became unreliable. So I was going to do a live demo, then I realized, hey, it might kill or maim somebody, so let's not do that. But basically, it's a little computer running something similar to, it's like a Unix kind of operating system, and very lightweight, taking RC inputs as like serial inputs. You can do it with PWM, which is an older kind of RC technology doing that as well. Got the telemetry back home so I can tell it to go places. I could drive this robot from inside the house. If you really want to check this stuff out, I would suggest RE Pilot. That will be a link to the project there. Really awesome. The way I got involved in this was doing some research for some people, might be related to that, about how these systems work. And you can totally make a dangerous thing with this, but that's not what I wanted to do. I didn't want to, hey, look, this is cool, I'm going to put a, paintball gun on it, whatever. No, I wanted to give it an alternative. I want to have a drone that drops seeds for wildflowers, for example. I don't want one that drops bomb. So, move forward a little bit more. Express LRS is, it's a radio PHY. It's more of a kind of a protocol stack. Has anyone here heard of LoRaWAN or LoRa? I know we have some hands. Yes, definitely. So LoRa's advantages: you have lower data rate, a long transmission, and very resistant to jamming. In this case, I'm not expecting jamming, but I'm just going to assume that, hey, if there's some kind of signal loss, I don't really want to fight that. Moving forward, the battle tested part of having big chunks of metal to electronics, especially radio, really screws them up. So that's something to be careful with. And ELRS is extremely helpful for that kind of stuff. Some of the older RC technologies, not so much. All right, so the GPS, or Global Navigation Satellite System, RTK is something that like surveyors use. It's triangulation or more. When you have multiple satellites, you can get a more precise location of where you're at. And in this case, I'm pulling, I guess, location data from all these systems, so Baidu, GLONASS, Galileo, whatever, using that to enhance the accuracy of the signal. But going even further into it, you have real-time kinematic, or RTK, which would be a base station standing somewhere and then a rover. So in this one, the rover is that little guy there. And you walk around with it and you can measure your position from one to the other because you'll get transmission from a base station over to the rover saying, this is my precise location, this is the signal I'm receiving, and it transmits correction data. So it's like a phased radio signal, best way to say it. And you can use that to get your GPS accuracy from maybe 2 meters down to centimeters or even millimeters in some cases, depending on how close you are to the base. So super useful, super overkill. Yeah, it wasn't that expensive. Thank you, AliExpress. So what I'm doing with this guy is, at my house, I've got a base station set up on the roof. Yeah, what's you said?
Question about the GPS.
Yeah.
So how frequently does that need to be calibrated as satellites are coming in and out of your
So it's not really calibrating it. It's sending the real-time correction data at 20 hertz. So 20 times a second, it updates the correction data, and I can use that to update my position data.
But your flag in the sand, it has to be consistent for that.
It has to be stable. You have a base station and then you have a rover. So in this case, the rover would be the robot, and the base station would be at the house or stick something on top of a car or whatever you want. One has to be stationary and it'll establish its location and use that to correct. You have to be within 15 kilometers more or less for it to even work. And outside of that, your accuracy drops off pretty dramatically. So there are different protocols used to transmit it back and forth from the base station to the rover. And in this case, I'm using network protocols or using ELRS itself. You can transmit some of this correction data back and forth between the robot, the rover, and your base station, whatever. So you can rent time from somebody who owns a base station. There are most states, the Department of Transportation, like PennDOT, TxDOT, which for Texas where I set this up originally, they charge a fee, or they require that, hey, if you're with a university, like, tell us what your proposal is, and we'll let you use our base stations. I mean, you can do that. It'll save you some initial setup costs, but you don't own the hardware. And if I own a base station, I can do whatever I want with that signal, and I don't have to be accountable to anybody. So, a little bit more. If you're interested in how RUPilot uses this, it uses something called an extended Kalman filter, which I am not going to get into here. It's a lot of math, it's very heavy, but you basically take inputs from accelerometer, satellite, optical tracking, everything else involved in here, compass, for example, to tell where the robot is, where the rover is, what position it's pointing at, how far it's moved, how fast it's moving, and the missile knows where it is, the robot knows where it is. GPS blending is another useful technology if you don't want to go down the road of RTK, which will add to your costs. You can just put another cheap $10 GPS module on there and bring your accuracy from 2 meters down to maybe 1 meter. And it's blending two signals from GPS, doing error correction to try to get you a closer average of where it's at. All right, so Mavlink is the protocol that I'm using for telemetry, or I guess it's the software that's going over the radio. It's a serial protocol, packetized, and very resilient to disruption. So you lose signal for whatever reason, you go behind a tree, you go behind a mountain, somebody's jamming your signal, whatever. It can still recover from that. Best part about it, though, is I can send the real-time correction, the RTCM data, from wherever over it. And that means I don't have to have a transmitter anywhere that's connected to the internet, if there's no cell service, if there's no whatever service. So it's running at 950 megahertz, so you get decent penetration through trees and buildings and things like that. So it works pretty well for my application. It's way, way, way overbuilt for what we need, but it's mostly a test platform to learn how to do this. And one of the great things about having a ground station is that you can program little missions for it and tell it where to go. So you upload the mission saying, hey, drive up and down the driveway and turn around at the end and make a little sound. it can do that. And you can tell it to do so, cut off all communication, and let it go. So the reason why these things are made anyway, as we've seen in recent history, there are times when you don't want to put a person in the loop, you don't want to put a person in danger for this kind of stuff. And, you know, have any of you seen the Chernobyl thing on HBO where they're trying to get the little tank robot in there to move stuff? Like, that is a great example of where you don't want a person, where you want something that's disposable instead of using a living robot like they did in that case. So ground vehicles, in my, I guess, scope of building here, I fly drones and aircraft. They have, I guess, like a limited loiter time, a limited lifetime, because you have to power them, you have to keep them in the air, you have to worry about that kind of stuff. They have great flexibility, but if you want to have something that's not going to disturb the neighbors, not going to get them to call in with cops because there's a weird drone flying over their house, that's an example. So you can use this for carrying larger batteries, or a large inverter in my case. So, hey, I need to drive it up the hill to cut up some debris. I can bring power tools wherever I want to. Little portable generator. I can use it to carry cargo, I can use it to carry, you know, whatever I really need to. And it's not designed to be specific for one thing or the other. It's general purpose, move things around. So this is something that's kind of in progress. I was waiting a little bit on funding for these things. I highly recommend, if any of you are doing LLM projects locally, you check out some of these guys. It's an AI accelerator hat on top of a Raspberry Pi. It connects with PCI Express, and it allows you to do some pretty fun stuff. So let's play a video, and hopefully this will work. Oh, fingers crossed, don't die. Potato quality. There we go. So what you can't see is the code for YOLO 11. I can't remember what YOLO stands for in this. It's a...
You only look once.
Well, I mean, there's that, but I mean, the computer vision model. You can run this model on the tiny little Raspberry Pi hat. Yeah, what's up?
You only look once.
You only look once. There we go. Yeah, it was like PJ Reddy a long time ago that made the original one. So in this case, I've programmed it to recognize the shape of a human. It's not doing so well at recognizing one human from the other. It's kind of, you know, specious. But it can recognize gestures, so T-pose and it will stop. You can give it different hand commands to do things. So in this case, I just wanted to follow me around. Say I'm going and walking around the driveway, walking around the garden, and I wanted to carry a wagon. Yeah, sure, perfect. I don't have to have a second person with me. If I'm the only one here and I load it down with like 300 or 400 pounds of mulch or something, yeah, no worries. So, why I wanted this, I wanted it because I'm insane. I built it, and I found a purpose for it afterwards, more or less. So, what I've managed to do with it, a lot of the garden work, hauling mulch, hauling plants, things like that, definitely saved me a lot of trouble. So, here is another wonderful feature. It's going to take a little bit to load this. So you can mount an accelerometer onto the FPV goggle system. And because I've got a gimbal camera, I can look whichever way I want to and be able to see whatever is in that direction. So you can use this for inspection of stuff if, you know, the reactor situation, if you want to go over there and look at something, you just drive it up the hill and take a look around. So very useful. It's a little bit terrifying to see yourself and knowing that if you run into yourself, it will do major damage. So, going a little bit further, I'm going to play this just because it's a thing. I weld some garbage, and in this case, I found a snowplow blade on Facebook Marketplace for $50. And I had to go drive like 45 minutes to get it, but it was a worthwhile purchase. The only problem is I had to cut it all into pieces and then weld a trailer hitch onto it so I could attach it to the front of the robot. Because, of course, nobody makes a plow attachment for a custom-made robot anyway. You end up with a result something like this. And what I'm doing is I'm cleaning trash out of like the border between our neighbor's yard. Somebody crashed a snowmobile up there like 15, 20 years ago, and it's just been rotting away. So taking it down in pieces, and then when we get down here and there's ice and whatever on the ground, you got a fertilizer spreader. You can just spread the salt all over the place before you plow. And I'm going to play some snow stuff. So I don't have a great picture of the front of the blade here, but it's essentially just pushing it along. And I'm supervising it right now because, yeah, if it went off into the road and a car hit it, it would do serious damage to something. I'm not so worried about the robot, I'm worried about it, causing the car to go off the road. But this is very useful. I can pilot this from in the house. I can just sit there in my bed and put on the FPV goggles and go plow the driveway and then get out there with the car. So let's move forward one more. Hello.
We're expecting more videos on Monday.
So that's my problem right now. I screwed up. On the 19th, we had the city come by and, spray the salt and do the plowing, whatever. I got some slushy, salty whatever onto the flight controller, and that is the worst thing you can do to electronics. It's to put conductive stuff on it. So, yeah, I don't recommend that. In this case, we had a sheet of ice on the ground, and it's so easy to just go through and break it up and scrape it off of there, so instead of doing it all manually with a shovel, oh my goodness. And I am not willing to pay somebody to go over there and do that for me. Because that's just why. I know I can do that. I'm strong enough to do it. But, my money, no. You don't get my money for that. So, yeah, live demo's kind of canceled here. But for the reasons I mentioned above, I've been injured by this thing many times. I could probably show you a wonderful scar here. I don't know if y'all can see that. That's from getting stabbed with a robot. I've been run over by it about 3 times. My wife has been run over by it twice. Her car has been hit by it a few times. My truck. Yeah, my little metal boy. He's
Coming to the emergency room. So what brings you in today, sir? Well,
yeah, pretty much.
Robot attacked me.
So what's terrifying is that other one where it's following you. While I was teaching it to do that, it didn't understand stop. So that's why it has the name Hugbot, because it will go through hugs, whether you want them or not, at speed. We're talking like 11 miles per hour. So you can outrun it, but only for so long. And it doesn't get tired as fast as the person. So, yeah.
How much does it weigh?
About 150 pounds. So it's a 2-inch steel frame, essentially. Square HSST, a hollow circular steel tube. So, yeah.
Does that weight, is that part of its function, or is it, could you make it lighter?
I could make it lighter, but it would give me a disadvantage in some cases. I lose traction if it's too light. So, in the case of the ice and snow, I'll actually put weights on this thing to increase traction. You'll get that with tractors and stuff like that. I've essentially gotten Home Depot buckets, poured concrete into them, and stuck rebar for handles. So, just plop them on there, and there you go. You've got 160 extra pounds of traction.
Can you make it detect your chip? Stop 1 foot away from you?
It has to get closer than that, which is the concern. Once it gets to maybe 2 meters, I start to get scared. So that's where I don't want to go any closer than that.
You need like a kryptonite belt or something.
Well, that's what the whole optical navigation is supposed to be about, to recognize a person and say, don't drive over this thing. But sometimes when you do things like bending over or you pick up a box, it says, oh, that's not a person anymore, let's keep going. So, yeah, go ahead.
So, I'm building an animal equipment myself, and one of the big concerns is safety. So I have a big button that's just this entire program. Do you have anything about it?
I have, the main power bus has a plug that's essentially a loop, and there's a big, got one of these.
So I'm thinking like a trigger, like a trigger. Like if we lose the signal from the trigger, it just stops.
So I've got one of these, hanging off of it, connected to whatever. So if I need to stop it, I can attach a rope to it and pull that thing. If whatever, just grab the yellow and pull it, and it will cut all power to the system bus. Having a remote cutoff, you can totally do that with a controller. It has the way Autopilot and a lot of drones work is you'll have like an arming function. So the robot is armed, robot is disarmed. When it's armed, the motors have power, there's signal going to them, and it can F stuff up. But when you disarm it, it's not going to be able to move around. So that's kind of like a soft control, but even then, I don't always trust it. So go ahead.
Can you put an e-stop on it?
That's essentially what it is. That's what it yanks the plug on the battery, pretty much.
Sure.
So you can technically ride it. It's super dangerous, but if you did that, you pull on the cord if you fall off. That's an example. I saw a dude over here yelling a question.
How much of it is machine, like obviously like the vision stuff is machine learning stuff,
Yeah.
but how much of the other stuff is machine learning versus just concrete code?
So the boundaries that's not machine learning, that's coded in there. So you can specify, geofencing is the term they use. And the waypoints, you can learn them. If I had the controller, I could show you. It's like an Xbox controller. You hit one button, it will learn location. You hit another button, it will go to location. So you set up 2 waypoints, you tell it to learn them, and then you can just hit another button and go back and forth between them over and over again. So like you were loading mulch, you could have it hit 20 or 30 waypoints, load it up with whatever, and then tell it to go back to where you're going to dump it. And then, like, my wife or my friend could go and load the stuff from the robot.
So you didn't have to write the code like how to follow a track.
No. That's handled by Autopilot, which is really, really powerful. And it has the ability to take in sensors, which I don't have yet because they cost money, and I just recently started a job. So not having money to fund this has been my bottleneck. But you can use LiDAR sensors, either 360 degree, or they make some, they're kind of an array of 8x8 point sources. So you can use that, say, if you're coming up against a wall. It'll know how far you are from the wall and avoid objects and actually navigate itself around it. And it will use that extended Kalman filter, the thing we mentioned before, to remember its location, remember it's supposed to be going, and then know how to route around it once it sees the objects in that. Another question.
What does your wife think about Hubba?
She hates it. She absolutely hates it. She does like it more now that she doesn't have to help with snow. So, and not needing to rope her in to help pull like wood chips and plants. Yeah.
So do you use the GPS, like have a point source of your personal GPS and have it don't get more than 2 meters from this point, no matter?
It's possible. Now there are risks with that.
Yeah.
I need to have a really accurate GPS because if it's 2 meters and the error margin is 2 meters, that means I'm within the error margin. So I would need to set up a second RTK location of a little rover to go around. I've tried it. I didn't have the money to get something decent. You know how that stuff goes. But it is feasible.
How do you learn this stuff? Because, again, I'm doing a project.
I
want to do it, and I just kind of ran into the wall a few times and just keep hitting the walls. I keep walking through.
I guess that's my superpower. I just figure stuff out and I get really inspired by spite and hatred for a project until I can make it work. So I saw another hand back there in the bottom or left.
The GNSS RTK.
Yeah.
I don't have an automatic lawnmower. Is that the same way that you set up an automatic lawnmower?
Yeah, that's one type. The other type is the buried wire method. So
the dog fence.
Yeah, like a dog fence, exactly. So that's what it uses to set its boundaries, and if you program it in with RTK, it doesn't need any buried ground. But it requires someone to run infrastructure for you. I saw a dude in the back.
Yeah, you mentioned like you're using Nova, they want to use detection. But couldn't you like take in from motion capture and wear gloves that are shiny or like a red shirt every time or something? Expect like when you bend down and pick up a box, really bright spots. Or well, have you considered other types of like object recognition systems?
I have, so what he mentioned before with having a beacon, I called it the leash, it didn't work so well. Just basic human detection and body position was the most reliable I could get. The video that you saw there where it was in color is not what the robot sees. The robot is completely monochrome. One of the upgrades that needs to happen would be a global shutter camera, and I'm looking at some models that, you know, higher frequency, no rolling shutter. So you won't have those kind of navigation issues. Dude over here in white hoodie. You had a question?
Yeah, why don't you use LiDAR?
A what?
LiDAR.
LiDAR? I tried. I really tried. LiDAR has its own complications. And one of them is if you're navigating around something with an object this large, it makes sense if you use it on a smaller robot, but when something is this big, you've got to put a more robust LiDAR system on it than what I have, which is essentially scrapped off of one of those little robot vacuum cleaners. So it's meant to operate outdoors. Outdoor LiDAR is powerful and expensive.
The person asking how much you learn more about when you get stuck, another one is asked on, like the local Slack community.
Yep.
And is Express LRS do positive connection detection? Like, will it, I know in some safety applications that involve remote radios, they have a system where if the radio connection is broken, it cuts off immediately. And
Yes.
I was wondering if Express LRS did that.
It does do that. Express LRS is bidirectional. You'll have transmitters and receivers, but they're both transceivers. They both pop back and forth. In this case, if I have a radio signal loss, it can actually trigger an action by the robot. So if it was an airplane, then I would say signal lost, immediately return to launch location and land, or return to launch location and loiter, do circles. In the case of this robot, if it loses the radio signal, it just disarms and sits there and waits. It does nothing. It will not start again until you have the radio connected to it. So that's a basic safety feature that's built into it, and that telemetry goes at about, in this configuration, 50 hertz. So 1/50th of a second, it will return that something has happened and stop itself. Anyone else?
This will be the last question then.
All right.
Have you found yourself to be more excited to do yard work and gardening?
It's my cardiovascular exercise, shoveling stuff and carrying heavy stuff. But, like, I know I'm going to get old. I'm already like 40. Well, I'm not going to say how old I am. But I'm already in my freaking 40s. It's not going to last forever. My knees are going to fail. My back is going to fail. All these things are going to happen. So with like insurance.
Robot could run into your knee.
It can run into my knees. It can take out my foot. It can grab my finger and rip them off. You know, all those things that robots do. Yes. I guess that's all we got.